Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to be solving problem 1715, okay? So it says, determine the moment of inertia about an axis perpendicular to the page and passing through the pin at O. The thin plate has a hole in its center, its thickness is 50 millimeters and the material has a density rho equal to 50 kilograms per meter cube, okay? So what do we have in here? Of course we have our thin plate, and as the description was telling us, we have that thin plate has a hole on it. And what we're trying to determine is the moment of inertia about this point O. Okay? So the first thing that I like to do in all of these problems, again, is just to write down my givens. In this case, the first given, they're giving me that the thickness, I'm going to write it as T, is equal to 50 millimeters. And what I'm going to do is I'm going to convert it into meters just because my density is given in units of kilograms per meter cube. So we have the same units. I'm going to convert this into 0.05 meters, okay? 0.05, okay? Then the density, rho, of this plate is equal to 50 kilograms per meter cube. Okay, so those are my two givens. How are we going to solve this problem? Well, in order to solve this problem, what we're going to do is that we're going to calculate the moment of inertia of this basically square, and we're going to subtract the moment of inertia that this circle will create. Since it's actually non-existent, we're going to subtract it from like our overall square. And after that, when we find the moment of inertia about my regular center of gravity, in this case will be in here where I'm pointing at, then we're going to take into account the distance from the center of gravity to my point O. Okay, so again we're going to be utilizing these equations, which is chapter 17. In this case will be 17.4, the equation where our moment of inertia about any point will be equal to the moment of inertia of the center of gravity plus the mass multiplied by the distance square. Okay, so how are we going to find this moment of inertia with respect to the center of gravity? So in order to do that, what we're going to do is utilize the equations given in the book, in the back of the book. So we're going to have that for a thin plate. In this case I call it a square for our square part. For a thin plate we have this equation, and for the circle we have the equation below. If you guys want to know where I found it, so we go to the book, and it's in this part of the book. And as you can see here, my thin plate, and since we want to know the moment of inertia about the z-axis, we're going to be utilizing this equation over here. Okay, so very similarly in my circular disc, we want to know in the z-axis, so we will be using that equation. And that's where I got those two equations from. Okay, so I'm gonna keep the book here on my side just so we remember where we got them from and what those equations actually mean, the A and B. So let's start with this problem. We have that we're going to say that the moment of inertia about my center of gravity is going to be equal to, we're gonna start with the square, so the equation is 1/12. So 1 over 12 multiplied by the mass. Okay, so the mass is going to be the density times its volume. So we know that the density is 50 kilograms per meter cube. So we multiply by 50 times the volume of a square. So we have to multiply one side times the other side. Right? We see them over here. One side times the other side times its thickness. So it's one of our givens, and since we already converted 0.05, okay, and this will be its mass. We need to multiply it by a squared plus b squared. And what is that a squared and b squared? This is where we go back to the book, and a and b is basically the size of this square, which we already know. So we're going to multiply this by 1.4 squared plus 1.4 squared, which is the size of our square in here. Okay, then we're going to subtract the moment of inertia of the circle, because the circle is actually a hole. So we're going to have minus 1/2 times the mass of the circle. Well, the mass of the circle will be, again, the density, which is 50, times the area. The area of a circle, in this case, the area times the thickness. So the area of this circle will be pi r squared. What is the radius? Well, the radius is 150 millimeters. If we convert that into meters, will be 0.15 square. We multiply it also by the thickness, which is 0.05. And then after that, so we did the mass. After that, we need to multiply by the radius square. And we figured out that the radius is 0.15, and we're going to square. Okay? We're going to plug all of this into our calculator, and the answer will give us equal to 1.5987 kilograms times meter square. Okay, so this will be our moment of inertia about our center of gravity. However, we're interested on the point O. So what we need to do is follow this equation. We're gonna need the moment of inertia with respect to the center of gravity, which we just found. We're gonna need the mass of this plate and the distance squared. So what I'm going to do is, okay, let's find out what is the mass of this plate. Well, the mass of this plate is going to be equal to the mass of the square minus the mass of the circle. Very similar to what we did before. So what do we have? Well, the mass of the square, we did it in here. So I'm going to copy all of that. That's the mass of the square minus the mass of the circle, which again we did it over here, which is, this is the mass of the circle. So I'm going to copy this, guys, and let's see what we get when we put this into the calculator. Okay, minus the mass, 50 times pi times 0.15 square times 0.05. This gives us a mass of 4.72, and it should be in kilograms. So now we have the mass. All we need to find is the distance. So the distance between my point O and my center of gravity is this line over here. It's a line. And in order to find it, what I'm going to do is we're going to create a right triangle with a 90-degree angle in here, right? And since we know this is a square, therefore there should be a 45-degree angle in here. Okay? So knowing that, this distance D should be equal to one of the sides, 1.4, this side, the hypotenuse in this case, which is equal to the 1.4 in here, multiplied by the sine of 45 degrees. Okay, so now that we know that, we're gonna say, hey, the moment of inertia about my point O is gonna be equal to, so now I'm following this equation, by the way, it's gonna be equal to the moment of inertia of my center of gravity, which we found to be 1.5987, plus the mass, which we found to be 4.72, multiplied by the distance squared, which is 1.4 sine of 45 degrees, and we're going to square all of this. And when we plug this into our calculator, let's see how much we get. So we got this plus the multiplication of these two guys. So that will give me a total of 6.23. We round to 2 decimal places, and the units should be kilograms times meter square. Okay, so just like that, we found the solution for our problem. So I really hope you guys like this video. Please push the like button, subscribe, and I'll see you guys in the next one.